Well, hello there. Welcome back to the Pit Stop Ranch. This video, we are going to be whittling on this poor unsuspecting generator mount. And then setting it up so we can fit as an offset generator on our 59A. And actually be able to use this thing in a hot rod. Okay, so we have our good generator, and I'd like to put it something like here. As a datum, we have a couple machine surfaces that are parallel to each other, which we're using to get the height datum. The problem is depth datum. Now I got this rough mark here where I want to mill to, but I'd like it to be 90 degrees so that, you know, this is perfectly straight, but by eyeball, of course, that's pretty hard to get. Now, nice thing about doing this milling, we'll know pretty quick whether this is steel or cast iron. So then we'll know what filler rod we're going to need when we weld on it. Now this assumes that this and this are parallel with each other and parallel with the axis up. Not 100% sure on that. Feel funny cutting on an 80 or 90-year-old piece of metal, but you know, they're not. It's not like it's rare, and it isn't like it isn't getting reproduced. Okay, if you look at the chips coming off, they're curly Q and not like dust. So it tells us this is cast steel, and therefore we can go ahead and just use standard filler rod. We don't have to worry about preheating or using a high nickel rod when we weld. And with that, we got the machining done we need to do. Okay, so we got our step machined in. I think it's pretty good. It looks pretty straight, eyeball, which, you know how good that is. Need to clean this up a little bit. Both sides kind of got a little bit of the radius. We're going to fill that with weld. Yeah. Okay, get rid of the radius that was there on both sides. Smoothened it out a little bit. Knocked off whatever this coating is. I think it's I'm not sure if it's a paint. I think it's paint. So I had a good exposed metal to weld to. Now it's this edge here isn't very straight, so based upon whatever high edges, we're touching the bottom there. So what I'm going to do is I need to deburr it, and then once it's deburred, then I can flip this over and do the finishing passes on this side to bring it to within get it to the 2 1/4 I want to get it to. Cutting oil helped a lot in that process. Got to make sure all of your chips are out of your surfaces, or else you blow your precision straight to hell. Straight to hell. Oh, the joy of using vintage speed parts, already used. The soft cast aluminum is deformed a bit and actually resulted in it not sitting flat the way it should, and needing a little bit of cleanup with the files. As you can see here, getting everything flat and paralleled. Did result in actually my clearances being a little bit more on my plate than I had originally wanted, but you know, that's the way it happens sometimes. Just chamfered the edges a little bit on the belt grinder. All right, cuts have been made. We have the gist of what we're looking to accomplish here. So next step is to reassemble our generator body. So something like this. Now I have a different challenge up here because we got the fuel lines run right here. And it'll be less slightly with having the wires up here versus underneath. I don't know, I feel better this arrangement. Alright. Alright, so got it marked out. I want to put a slot here that fits 9/16 course, and that'll then give me this. Now, one of the challenges on it is there might be an inch throw at most, and even then probably closer to a ½ inch throw. So getting the right size belt is going to be a challenge. But worry about that once we get this mounted. Now, a bunch of ways to do this would be to go ahead and drill a couple and then gouge it out. However, my largest drill, I believe, is ½ inch. No, actually, I've got very large, but I do not have 9/16. So I'd have to cut it and then whittle on it, and that would create a kind of probability of kind of an ugly look. So what I want to do is go ahead and use my little drill mill to go ahead and take a 9/16 end mill and go ahead and mill this. Biggest problem is this is being filmed on the 1st of January, and no place that sells end mills is open, let alone 9/16 bolt, because we have the 9/16 bolt, but we need a 19/16 bolt that's like that long right there. So okay. Here we have, of course, the generator yet again. And here's the plate with which we're going to use to modify the generator. Off camera, I went ahead and milled a groove in it using my crappy little drill mill. Did an alright job. You know, did what it needed to do. Next, I'm going to go ahead and weld these two pieces together. Now, some things to think about. This piece here, you got to make sure is materially compatible with this piece here, and both pieces are compatible with the filler rod you're going to use. In this instance, based upon the chips that came off from this, I have decided that this is cast steel, which if it's cast steel, groovy. It's compatible with the standard welding rod, and we can weld this thing up. If it came off, if the chips came off differently from the milling process, then this might have been cast iron, and if it's cast iron, then we'd have to do like how we repaired the cast iron engine block. We'd have to preheat this to roughly 900 degrees, which case at that point there we'd have to actually completely disassemble this, which isn't a problem because off camera I took the opportunity to drop this thing on the floor, knocking the pulley loose, and then having to dismantle and moving the bearing around. And so I had to dismantle this whole thing and get the proper depth and settings so that the everything clearance properly once again. So anyways, going back, if this was cast iron, have to completely disassemble this whole thing, have to preheat it, and then use a high nickel rod. They make specific filler rods. I've had success with using just a 304 stainless rod. Professional welders out there will roast me, which is justified and fair. But since this is just cast steel, I think we can just get away with standard mild steel. If I weld this all up, and then after it's cooled down, I got a nice big heavy chamfer, and it cracks in like parallel. If the cracks develop in parallel with the weld, then this is cast iron. If you do not do those steps, what will happen is as it cools, it will create microfractures next to the weld area that will then, within the heat zone or at the edge of the heat zone, and then as it cools or as it then gets fatigued or used, it'll crack right there, just right there, no problem. So we'll have to keep our eyes open to make sure that this thing doesn't crack, in which case I've misread the material and it'll take considerable more machining and engineering on my part to make this work properly. In which case, in all odds, I've completely ruined this. And I am sure that there should be a percentage of the audience who are not haven't screamed already in the comments about why'd you ruin a classic or why did you ruin original parts. Feel free to leave those comments down below. I really appreciate them. So, we're going to weld, of course, this plate onto here. But this plate here is 1/4 inch, which is fairly stout. But it's going to have a lot of loading this way, as well as this way. This way is probably #1 loading. But the plate itself should be able to take that. The intake manifold might not, the aluminum intake manifold might not, but the plate should by itself. However, the loading this way, you have the weight of the generator pulling it back this way, but then you're going to have the pulley pulling it back this way, which are going to somewhat cancel each other out. However, it's still going to have a lot of loading. So, what we want to do is put some ribs along the sides here to stiffen this up. So I got this hunk of 3/8 bar. I'm going to whittle off some chunks, and we're going to go ahead and stick them on the edges after we've welded this onto this. Okay. Got everything held in place with magnets. Welder's turned on. Get this thing tacked. And good news, it welds just like steel. It does not weld at all like cast iron. So that doesn't mean it ain't stainless steel, and we're still totally screwing up, but you know. I'm right-handed, but I'm better at holding the torch with my left. That was just been the way I've learned how to TIG weld, but I'm going to try it this way so maybe you can see a little better. Well, let's do a test fit, see how it works. Oh, and there you go. Pretty well lines up. Next step, I need to get a belt on there. Let's have the belt on. Then I think we'll be ready to stab this thing on the run stand and fire it off. And there we go. Feels pretty good and strong and firm to me. Only time will tell. Totally welded like steel, so pretty sure it's cast steel. So I think we're in pretty good shape. Feels good and rigid. There's no flex there at all. Quite happy with this arrangement. Now, justifiable criticism on us here. We cut up perfectly good, original, chromed up mount, generator mount, in order to make this monstrosity. And one can argue that there's might be a finite supply of these. I would disagree. There are a number of manufacturers making new ones, including offset ones. There's one, I believe, available from Wieland or Offenhauser. I think it's Offenhauser. I think Offenhauser has one available. That you just unbolt this and do it. So, why did we do this? We got the generator already modified to 12 volts for pretty reasonable price at a swap meet. At the end of the day, we don't have much into doing this. And if you replace a modern TIG welder with oxyacetylene welder, you have more or less how a hot rodder could have done it back in the day. Did they do it this way? Maybe they did, maybe they didn't. But this being a TROG build, though reproduction parts are acceptable, I think homemade touches such as this are appreciated. Let me know what you think on that last statement down in the comments below, along with all your hate and vitriol regarding cutting up old school parts to modify and change and make them function in a way they're not intended to. Down below in the comments, love reading every single one. And if you enjoyed this video, please hit the like button, and if you haven't done so, please subscribe. And until next time, have a mod-tastic day.